I'm Anil Kumar, sharing with you a question from the book. My student Maria needs help to understand it. It is question number 11, page 305, Rates of Change. Author is Nelson. The question is, given the function f of x equals to x minus 2 divided by x minus 5, determine an interval and a point where the average rate of change and the instantaneous rate of change are equal. Maria, what I have done is that I have created actually 3 videos. All of them are linked. And you need to go through all 3 of them to really understand the concept. In one of the videos, I have derived the expression for instantaneous rate of change for this particular function, f of x equals to x minus 2 over x minus 5. So in short, instantaneous rate of change for this function at any point, let us say the point is a, will be what? Will be equal to f of a plus h minus f of a divided by a plus h minus a, right? So that really means I have to replace this by x by a plus h to get fa plus h. So we get a plus h minus 2 divided by a plus h minus 5. Take away f of a, which is a minus 2 divided by a minus 5 divided by h, right? Now you can simplify this, cross multiply, bring the terms together, and when you do that you get a minus 5 times a plus h minus 2. Take away a minus 2 times a plus h minus 5, correct? In the numerator, denominator will be h times a plus h minus 5 times a minus 5, right? You should remember in this expression, h is very, very small. So when you solve for the numerator, most of the terms will get cancelled, and what you will finally get will be minus 3, which is 5 minus of 5 minus 2. You'll get minus 3 over a minus 5 whole square, right? Remember, h is very, very small as compared to 1. It really approaches 0. So h will first cancel out, and then you can substitute 0 for this h. So when you simplify, you'll get this expression for instantaneous rate of change, right? So I'd like you to do that part. Now the second part is that actually the question is, determine an interval and a point where the average rate of change and the instantaneous rate of change are equal. So that is an expression for instantaneous rate of change, and we'll try to find a point by getting the value of a. Now to find average rate of change, let us select 2 easy points to work with. So strategy here is f of 2 is your x-intercept. So let me say, what is f of 2? If I substitute 2 here, I get 2 minus 2 and 2 minus 5. 2 minus 2 is 0. As expected, this is x-intercept. F of 2 is 0. Now another easy point could be if I can make denominator 1 or minus 1. We don't really want to take fractions, so let me take f of 4. So f of 4 will be 4 minus 2 divided by 4 minus 5. That gives us a value of minus 2, correct? So we have f of 4 and f of 2. Now, so what is the average rate of change between these 2 points? The average rate of change, let me write average rate of change as equals to the value of these functions. So let me write here as f of 4 minus f of 2 divided by 4 minus 2, correct? So on this right side, as you know, I love to just do all the solution in half the sheet. F of 4 is minus 2, so we get average rate of change as equals to minus 2 minus 0 over 4 minus 2 is 2, which gives us a good value of minus 1. So, if you select your points carefully, you get easy values to work with. right? So now we know that the average rate of change between the 2 points selected, and the 2 points for us are 2, 0. This is the x-intercept. The other point is 4, minus 2. There the average rate of change is minus 1. Now we need a point on the graph of this function where instantaneous rate of change is minus 1, right? Now we know general expression is minus 3 over a minus 5 whole square. So we can equate these and then find, right? So we need instantaneous rate of change equals to average rate of change. This is what we need, correct? So we have our general expression, which is minus 3 over a minus 5 whole square. Let's equate it to the average rate of change of minus 1. So minus minus cancels. We can cross multiply. So we get 3 equals to a minus 5 whole square, right? Now we have to solve this equation. So we can do square root. Whenever you do square root, you get always plus and minus. We get plus minus square root 3 equals to a minus 5. Is that okay? And that gives you the value of a. As you can see here, you get actually two values of a. Let me change the ink also. So if I change this value, you could write here itself, but I prefer to write here. You can write a as equals to, if I take 5 on this side, 5 plus minus square root of 3. So in fact, I got two values of a at which the instantaneous rate of change is same as average rate of change between these 2 points, right? So you can actually verify it. Now can you explain me why I got these two values, and that too why 5 plus minus square root of 3? Well, that's a question for you to answer. You can pause the video, answer this question, and then look into that solution also, since I think I should tell you that also right now. Okay, so what I will do now is try to sketch the function itself. It is f of x, x minus 2 divided by x minus 5. So we can 1, 2, 3, 4, 5, 6, 7, 8, let's say 9. Okay. So 1, 2, 3, let's say. Okay. So we have vertical asymptote at x equals to 5. This is 1, 2, 3, 4, 5. So there it is. So this is my vertical asymptote. Let me draw it here. And the horizontal asymptote is that ratio of leading coefficients 1, right? So let's say this is 1 for us. Let me draw here horizontal asymptote. Okay. Now, as you can see, the x-intercept is at x equals to 2, so which is here x-intercept. We took a value f of 4 as minus 2, so 4 is here. This is 1, this is 2, minus 2. So that is the point f of 4. The y-intercept will be 2 over 5, which is kind of very close to this, correct? So with these points, I can always join them and sketch the function, right? So as you know, it's approaching minus infinity here, and this is kind of like this. That's the rational function. This is the point where the two intercepts are, two asymptotes are intersecting. You know, this graph will be symmetric about this point, right? So here we have 1, 2, 3 units, 1, 2, 3 units, 1 down, 1 up. So we have a point here, right? So let me just sketch this point kind of like this. I'll explain you again how I got this point at 8. Okay, that's fine. So this point is 5. This is 2 for us. Okay, that's a y. And this is 1 for us, y-intercept. Now, what we really did was that we took 2 points. One was f of 2, the other one was 4. So these were the 2 points which we took, and we say this is our secant line, joining like this, right? So we have a secant line going through these points. And we actually found an answer which was 5. 5 is here. Plus minus square root 3 will be kind of here, right? So it will be plus minus square root 3 will be kind of here on the graph. You'll find that that line will be parallel. If you do minus, you are on this side. If you do plus, you will be on the other side. So you'll get a line which is kind of like this here. And that, so 2 points we got because these two graphs are symmetric, right? About 5. And therefore, we got this value which is symmetrically placed also. So that explains the answer also. And as you can notice that we actually on this graph have 2 different points, one on each half of the graph, which will have the same instantaneous rate of change as the average rate of change for the points which we select. You could select any of the points and get your answer, right? Anyway, I'll give you a link on how I derived this after that step also at the end of this video, so you can look into that and check your answer. But I hope this helps you to understand the concept. Thank you and all the best.